Today, let's discuss futuristic automotive technologies already in testing. And it will probably be an everyday reality for all of us. All of us in the short term. Let's start with the first and most obvious one, autonomous driving. We all know that this has stopped being a distant dream and has become a palpable reality with brands like Tesla. However, as I mentioned earlier, it will now become part of our daily lives and we will move towards next-generation autonomous driving. For example, in cities such as Leganés, Spain, driverless city buses are already in circulation, as part of pilot projects that seek to evaluate their viability and safety. These vehicles are equipped with advanced technology such as radar, laser, cameras, RGB and thermal imaging, and ultrasound sensors that allow them to navigate the streets safely and efficiently. Additionally, it's expected that by 2025, around 13% of vehicles on the road will be equipped with advanced driver assistance features, known as Level 3 autonomy. These technologies, which include systems like adaptive cruise control and automatic braking, not only enhance the driving experience but also prepare drivers for the transition to full self-driving. Companies like Google, Volvo, Daimler, Tesla, and Apple are leading the race in developing autonomous vehicles, testing them in real-world environments and racking up thousands of miles of experience in driverless operation. These initiatives aim not only to improve road safety, but also to provide a more comfortable and efficient mobility experience for everyone. Let's move on to the second technology, cars that talk to each other. Connected vehicles equipped with Internet of Things technologies. IoT will offer drivers a more seamless and personalized experience, while improving road safety. By 2025, more than 75% of all vehicles sold globally are expected to be connected to the Internet, enabling remote software updates and real-time data sharing. With the implementation of 5G networks, vehicles will be able to communicate with each other. V2V and the infrastructure. V2X infrastructure, also known as Vehicle-to-Everything, significantly improves safety and traffic efficiency. This connectivity will allow, for example, one vehicle to warn another about hazardous conditions on the road, or coordinate to optimize traffic flow at intersections without traffic lights. Plus, 5G connectivity will open the door to new forms of entertainment and services inside the vehicle, turning the travel experience into something more interactive, active, and personalized. From advanced virtual assistants to high-definition multimedia content, the possibilities are practically limitless. Now let's talk about cars with renewable and infinite energy. Solid-state batteries represent one of the most promising innovations in the field of energy for electric vehicles. These batteries offer a higher energy density, which translates to longer ranges than current lithium-ion batteries. Additionally, they allow for faster charging times and increased durability, addressing some of the main concerns of consumers regarding electric vehicles. The arrival of these new batteries will be another step toward making electric cars more accessible, allowing for the development of more affordable vehicles. Prices, much more affordable than those addressing current EV issues. Manufacturers and research centers around the world are investing in the development and production of these batteries, anticipating their integration into consumer vehicles in the near future. And even though many may not like it, the shift to mass electrification is inevitable. The transition to electric vehicles is one of the most prominent trends in the automotive industry. Governments around the world are implementing regulations to reduce carbon emissions, which has sped up the development and adoption of electric vehicles. Global electric vehicle sales are expected to go out of business. They are projected to reach 26 million units by 2030, accounting for 28% of all new vehicle sales. Manufacturers such as General Motors have announced significant investments in the electrification of their fleet, allocating more than $35 billion by 2025 in electric and autonomous vehicles. This initiative aims not only to reduce the carbon footprint, but also to provide consumers with more sustainable and energy-efficient options. In addition, the charging infrastructure is experiencing remarkable growth. The installation of electric vehicle charging stations is expected to grow by 24% annually until 2025, making it easier for these vehicles to be adopted on a large scale and removing one of the main barriers to their popularity, range anxiety. We also need to talk about the technology that changes color and self-repairs. The automotive industry is experiencing impressive advancements in technologies that allow vehicles to change color and autonomously repair their paint. These innovations not only provide customizable aesthetic options, but also enhance the durability and maintenance of the technology. The maintenance of vehicles. One of the standout technologies in this area is the use of e-ink, similar to what's used in e-readers. BMW unveiled its 9Flow model, which uses this technology to change the vehicle color quickly, applying electrical signals. The electrochromatic technology from ink adds different color pigments to the surface. Select the desired shade with just the push of a button. This ability to change color not only offers aesthetic advantages, but can also influence the vehicle's energy efficiency. For example, a light color can reflect more sunlight, keeping the car's interior cooler in warm climates, while a dark color can absorb more heat in cold climates. Another innovation in this field is thermochromic paint, which changes color in response to temperature. These coatings contain pigments that react to heat, allowing the vehicle to change its appearance when exposed to temperature. At different temperatures, for example, when hot water is applied, the paint can instantly change color, returning to its original shade as it cools down. This technology offers a dynamic way to customize the vehicle's appearance and can be used to create unique visual effects that change based on environmental conditions. In addition to color-changing capabilities, automotive paints with self-healing properties have been developed. Researchers at the Leibniz Institute in Germany have created a pigment with polyurethane molecules that allows the paint to repair itself when exposed to ultraviolet light. This advancement means that minor scratches or damage to the vehicle's surface can disappear without the need for manual intervention, maintaining the car's appearance and reducing maintenance costs. These innovations in self-healing, color-changing paints represent a significant advancement in vehicle customization and maintenance, offering drivers the ability to customize and self-heal their own color-changing paint. It's a more adaptable experience and reduces the need for costly repairs. Finally, while we won't specifically see a robot sitting in the driver's seat driving our car, we can expect that it will become a reality very soon. The scene from the movie Upload, where cars drive themselves, and we shouldn't have to do anything more than watch TV, scroll through social media, or whatever we want. The vision of vehicles moving without human intervention, controlled by advanced robotic systems, is getting closer to becoming an everyday reality. These cars, driven by robots known as autonomous vehicles or robot access, represent a revolution in how we understand mobility. Currently, various companies and governments are investing in the development and testing of autonomous vehicles. For example, in San Francisco, it's already possible to request an autonomous taxi just as easily as a traditional service, like Uber or Lyft, highlighting the significant advancements in this technology. In Europe, the Community of Madrid is preparing a mobility law that will promote the deployment of autonomous vehicles in the region. The legislation, expected to be approved in 2025, aims to create a common framework to avoid contradictions between municipalities and ensure mobility throughout the Madrid region. Leading companies in the automotive industry are showcasing remarkable innovations in the field of autonomous vehicles. Tesla, for example, has announced the Cybercab, its first robotaxi without a steering wheel or pedals, costing less than $30,000, with production expected to start in 2026. This two-seater, fully autonomous vehicle will use induction chargers and promises to revolutionize the concept of the automotive industry of personal transportation. On the other hand, Mercedes-Benz is testing vehicles that use a combination of sensors, cameras, and GPS to detect their surroundings and navigate autonomously. These tests reflect the industry's commitment to developing technologies that enable safe and efficient driving without human intervention. Despite progress, mass deployment of autonomous vehicles faces significant challenges. Technological aspects like accuracy in detecting the environment and making decisions in complex situations still need development. In addition, there are ethical and legal considerations that must be addressed to ensure a safe and acceptable integration. For society, collaboration between governments, companies, and communities will be essential to overcome these obstacles and take advantage of the opportunities that robot-driven cars offer. With the ongoing progress in research and development, it's likely that we'll see a wider adoption of these vehicles in the near future, transforming urban mobility and redefining our relationship with transportation.